Dr. Michael Weber, Josie Centennial Professor of Energy Resources and Professor of Mechanical Energy over at the University of Texas at Austin. Welcome and thanks for joining me today. It's good to see you.
Thanks so much for having me. It's fun to be part of the conversation with you.
Yeah, of course. And I've been interviewing you, Michael, for several years now, and you're one of my favorite resources who can really speak to this full spectrum of change that we're experiencing in the energy industry today. And we have no shortage of topics to hit ahead of your keynote address at the Itron Inspire event on Tuesday, October 8th in Palm Desert, California. So we'll be previewing some of those remarks throughout this conversation, and anyone interested in attending can visit itron.com/inspire to learn more. We can't have an energy industry conversation or even start one without talking about load growth in data centers, can we? So I want to start there. Every forecast that demand for electricity from data centers specifically will double by the end of the decade to 9%. When you think about this load growth story, which is largely unprecedented, at least in the modern history of utilities, how should we be framing whether fear or opportunity when it comes to this kind of new territory we're wading into?
I think you said it right. It's fear and opportunity, and we are at an inflection point. And I'll maybe back up just to give a little bit longer view, which is the energy industry is always changing, so change isn't new. But there are periods over time where you get accelerated change with things like the Industrial Revolution or the Second Industrial Revolution or the rise of rural electrification and gasoline engines for transportation after World War II. And now we have another rapid era of change as we have load growth in the power sector. And this load growth will be data centers and artificial intelligence and electric vehicles and electrified industrial loads and heat pumps for heating. There's just a lot of things going on to drive load growth, and artificial intelligence and data centers are a part of that story, but they're not the only part, I would say. And this is an important change because for the 20 years before this, load was pretty flat in the United States. Our consumption stayed about the same year over year for 20 years in a row, despite significant population growth and economic growth. So now we're back to an era of rapid growth, which we haven't seen maybe for like 90 years or something. And we've lost some of the muscle memory of how to build things quickly or how to get approvals and permits and regulatory permissions to do things. So we just got a lot we have to do pretty quickly. And that means we need to throw a lot of tools in the toolbox. We need more power plants, more transmission, more distribution, but also more grid edge technologies, more smarts around how we use the data and analytics to optimize what we do have with the assets. So we're going to have to use every tool, and a lot of the data-driven technologies at the end, which will be enabled by AI or artificial intelligence in many cases, will be part of the solution to the demands that AI will put on the grid. So that's kind of the irony there. But a lot of change is a pretty exciting time. If we do it the wrong way, it'll break the grid. If we do it the right way, it will improve performance, lower cost for everybody. So I'd say let's do it the right way.
Yeah, what's the worst that could happen? If those are your two lanes, let's pick the latter
pick the good
instead
one?
of the former.
Yeah, I say we pick the good one. But it's let me give one example on that just with electric vehicles. Electric vehicles are rising in prominence because they're cheaper to operate, they're higher performing, they're quieter, they're desirable, they're cleaner, they're fun, all this kind of stuff. So we expect electric vehicles to dominate the light duty vehicle market for a while. And Norway is an example of this. They basically don't sell combustion engine cars anymore, only electric vehicles. In the United States, where we have a couple 100 million vehicles, if we plug them all in at the same time on the grid, and imagine each one's like 5 or 6 kilowatts, and you've got a couple 100 million of them, that becomes a lot of demand on the grid in a way the grid can't handle. But if we spread out how we plug in those electric vehicles, if we manage the charging in an intelligent way, and we plug them in when we have excess capacity or at night or this kind of thing, it actually lowers the cost for everybody because our grid is now divided across more kilowatt hours and more users. And so those EVs either break the grid or save the grid depending on what time of day you charge them. And that's, I think, symptomatic of a lot of the things happening with the grid right now.
That's a great example. And I was having a conversation with an executive over at PG&E a couple of weeks ago about this data center topic. And they approached it from a similar viewpoint that data center customers and developers are coming to them and saying, I want to build a big data center right there, and I need 500 megawatts of electricity. And PG&E is saying, well, let's like sit around the table, look at a map, and well, this node's a little lighter, so maybe we could put you there. Would it make that big of a difference? You still got your comms infrastructure, you still get the electricity, but we can build upgrades that we know we're going to need in 5 years anyway. So why don't you go there, and then we can kind of align our efforts. And I think that's another one of these like unique approaches to the question of is it going to be doom and gloom, or is it going to be opportunity? And I think we have some choice there.
Yeah, and I think there is a race. You kind of mentioned that there's these large data centers. So a large data center maybe is 500 megawatts today. We have the hyperscalers coming, which would be 1,000 to 5,000 megawatts. A large data center a decade ago was 5 megawatts. So we've already gone from 5 megawatts to 500 megawatts. Now we're talking about 5,000 megawatts. That's really incredible. We have a new research computer at the University of Texas. It's a computer, like one research computer, 30 megawatt peak demand. It's a $1 billion project, $500 million to build the computer and $500 million to operate it over 10 years. It's a big national science foundation, open science computer used to do some of the most complicated calculations you can imagine. One computer, 30 megawatts. So it's growing a lot. And the challenge for the data center people who really get a lot of value out of the data and offering different services to humanity, some of it's streaming, some of it's artificial intelligence. So maybe it's not all valued the same, but they're in a hurry. And if you go to utilities, say I need 500 megawatts capacity for my data center, they might say, okay, great, we'll hook you up in 2029. And they're like, we can't wait 5 years because we have customer demand right now. So what can we do to get these going faster? And that's where these other technologies and options will become really important, which could be solar and battery microgrids behind the meter, gas microgrids behind the meter. You have some companies talking about buying a nuclear power plant that's 40 years old that maybe has 20 years of life left and moving it behind the meter. So I think we have to look at every option, and any technologies that enable more of these options will accelerate the adoption of some of these new facilities. And these new facilities come with useful services for the economy, and they come with jobs and other things. So I think we want to see them build, but we have to solve that on how to get them connected more quickly. And there's also supply chain stuff. They're competing for the same transformers the utilities are. So it needs to be collaborative. It is an opportunity. It is a crisis. And I bet we'll see a bunch of options designed in the near term to accelerate their connection. And then utilities will catch up and expand their capacity to fulfill that over the long term.
And grid edge intelligence plays a role there too, and we'll talk about that a little bit more. And I'm sure that will be a topic of discussion at Itron Inspire, as that's kind of right in Itron's wheelhouse. I do want to ask you, as you also lead the Weber Energy Group and do a lot of research and consulting on these kinds of challenges and leading teams of researchers and folks over at the university, what do you think our blind spot is with this topic? Like where are we not paying enough attention as it relates to the load growth story?
I think the load growth story has two things that come to my mind. One is a mismatch in timing between load growth, supply growth, and transmission growth. You can build new load in 2 years or less. It's like a data center or a battery factory or something like that, or all these electric vehicles. You can build a new power plant in something like 2 to 4 years, which is, say, a wind farm or a solar farm or something like that. But you build new transmission in something like 6 to 20 years. So the load growth is outpacing the supply growth, which is outpacing the ability to move electrons from one place to another. And that creates these disconnects where we got to get the power from one place to another, or leverage existing assets, use them more intelligently with the grid edge options, or build things more quickly. So that's just a mismatch in timing. Permitting reform, getting things built more quickly is a part of that. There's bipartisan consensus this needs to happen. In fact, there's a bill out by Senators Manchin and Barrasso on that issue. It's not law of the land yet, but it's getting some traction. So I think there's some bipartisan acknowledgement that it would be good to build things more quickly, which means permission structures need to happen more quickly. And AI might be a solution there, by the way, because a lot of the permits and applications are standard template information. What's your project? Where is it? It basically details that you can have AI reviewers do for you more quickly. So you spend your human time on the parts of the project that are more specific or have a variance and that kind of thing. So I think there's an opportunity of permitting reform to move more quickly, because right now we have a mismatch in load growth and supply growth and transmission growth.
Yeah, average lead time to bring a data center online in this country, I believe, is around 36 months in any region. Like, pick whatever region you want, even the ones that are, the quote unquote data center alley over in Northern Virginia or, Southern California, whatever. That is too long for those customers. They want the power. They want it quickly, even if you just give them a little taste in the beginning.
You have data center developers making the data centers before they know who the customer is to move more quickly. And so that will shorten the timelines. In Texas, we built about 5 gigawatts of data centers in less than 2 years. And that was when China kicked out a lot of the cryptocurrency miners. They essentially moved to Texas. So it can move faster than 3 years in some cases.
Yeah, really interesting. And you mentioned, so there's kind of two sides of the coin here, that AI is going to cause all this demand, but AI can also address a lot of the challenges we face. And I teased a little bit of the grid edge intelligence and the amount of data we have in front of and behind the meter now with, advanced metering infrastructure and this wave to, real-time communication with these assets to inform not only utility operations, but investments in the long term. So how do you think we should be framing also how an AI and this kind of advanced tech is going to enable smarter system building, smarter operation of the grid as we know it?
The way we feel artificial intelligence today is as an exacerbant on some of the strains in the grid because of the demand for power. So it needs a lot of power, it needs it quickly, and we feel that strain. In the long run, in the big picture, it's actually not that big a deal. It's a few percent of total electricity use, but it's like 100% of the next megawatt hours. So if we look on average, it's a small fraction of what we need. But in a local region, it might be everything that this utility can provide, every new power plant or every new hookup. So it feels very acute right now, but actually isn't huge on a overall macro view or long-term view. Nevertheless, we feel it right now, this sort of tension between we've got 100 megawatts of new capacity available, should go to a data center or should go to subdivisions in a factory or something else. So there's some tension there. So AI feels like a strain on the system. However, we can use artificial intelligence tools to accelerate the discovery of novel materials and chemistries for new batteries. And those batteries might have higher performance. We can use artificial intelligence to accelerate the designs of fusion reactors so we get more clean supplies that are available in the future. We can use artificial intelligence capabilities to manage large data sets to optimize how we use the grid. And then we can use artificial intelligence at the grid edge to do this. So AI is first a strain on the grid in terms of the power we need for the data centers where the training is done. And the training takes like 6 to 9 months to train up a new large language model, for example. And then you do what's called deployment or inference, where you deploy the artificial intelligence for years. And then it's not as energy intensive once you're done with the training. And we can use its trained model to help optimize the grid. So artificial intelligence first, when it's being trained, is a strain on the system. But once it's capable and can be used for deployment and inference, helps the system. Frankly, that's not much different than students at college. They're a strain on the system the first couple of years as we're teaching them. And then they're really handy because they can solve some problems. So it's the same way with the data centers and artificial intelligence. And I think we'll find that they will end up finding more efficiencies and benefits in the system for us than they will cause in terms of strain. So the benefits to cost will definitely outweigh it. And by that, I mean, we'll get many more benefits than costs from artificial intelligence.
As we land the plane here, what are the policy considerations to keep in mind as we talk about, especially AI, because you see all the innovation happening on the consumer side, and those companies and those solution providers can kind of throw whatever they want at the wall, and if it messes up, they'll start over. If customers get mad, whatever. Energy companies, utilities, more specifically, N-1, like the lights got to turn on, and they have been apprehensive to technology advancements in the past, and I think as they're all approaching the opportunity of AI, there's the low-hanging fruit of like automating call center operations, putting a chatbot out there. That's one thing, and you can firewall that. But when it comes to actual utility operations and customer data and really sensitive areas that we're often not comfortable with, how do you think we should be framing how far to go with this?
I think it's our job to learn the new tools and figure out how to use them in a way that's beneficial and not hurtful. And artificial intelligence is a more powerful tool, so it might be even more helpful and more hurtful. And so we need to be mindful. The concerns I have around artificial intelligence are really not in the utility world. I'm more worried about the ethics of AI. I'm worried about intellectual property protections. I'm worried about whether artificial intelligence can be used with malicious intent. We've already seen it has been with disinformation and misinformation campaigns. I really worry about that, and the ethics have not yet led to policies, rules, and regulations. It feels like it's a very wild, wild west. And we see a lot of bad behavior. We also see a lot of intellectual property concerns. I can ask ChatGPT or you name your AI platform to write an op-ed in the style of Michael Weber, and it will do that. And so my essays have been used to train up the large language models that now other people can use. Just had a dinner conversation last night with two playwrights in Austin. They wrote the most latest Meg Ryan movie of all things, and they were talking about this battle with artificial intelligence with the Hollywood studios is around who owns the intellectual property. And if you're using artificial, so my concerns about AI are actually not in the utility space. I think it's pretty exciting for the utility space, for the energy space, and for the solutions it brings. But I have a lot of human concerns around artificial intelligence and what it does to the human relationship and what it does to the intent of how we engage with each other. And so those are where my concerns are. And I guess that's good. Like we'll solve the technical problems. Let's go focus on the humanistic problems.
Well, I can tell you that this is the real Dr. Michael Weber right now, and you can see him too at Itron Inspire in Palm Desert, California, October 8th. Michael, it's great to see you.
Yeah, thanks so much. Great conversation.